All right, so for the first one, I wanted you to come up with what the assumption is, basically. I said another word for it, but that doesn't really, that's not really a good way of asking. So it's basically what the assumption is when you're doing an indirect proof. What is the assumption? What do we usually assume when that the conclusion is false? Yes, okay? So you could have said false. Whoa. That was way uncalibrated. Okay. So false conclusion, we have a bit of a shadow, it looks like. All right, the next one, we are writing the assumption you would make to start an indirect proof. So if the assumption is a false conclusion or that the conclusion is false, what would be the assumption for number 2? X is not equal to 2, because first thing you need to identify is the conclusion, which is x equals 2. Then you need to make that false. So x would not be equal to 2. And that's all you have to write. For triangle CDE, okay, it says it's equilateral. It has a base CE. That doesn't necessarily matter, but you have CD being congruent to DE, DE being congruent to CE, and then CD being congruent to CE. Basically, all the sides are congruent is what it says. So again, what would be the conclusion, and then what would be the assumption for this one? Selena, what would be the conclusion for number 3?
False.
What's false?
That is equilateral.
No, that's not the conclusion. What is the conclusion? Okay, so you would say CD does not equal DE, or is not congruent to DE. DE is not congruent to CE, and CD is not congruent to CE. So you would just put the not through all of them. So that would be your assumption for number 3. All right, number 4. There's a trick to number 4 that we talked about where you're trying to come up with an inequality. You need a range of values for x. Okay, so you need like the lowest range of value and the highest that it could be. So if we have x, how can we describe our values and what they could be? Anybody remember the trick? Okay, subtract them, so it has to be greater than that, which would be greater than 2. You want to put your variable in the middle and just read from the variable. So that says x is greater than 2, and then what would be x? What would x need to be less than? Yes.
14, because you add the
14. Yep. So you add 8 plus 6, and you would put less than 14. And again, that reads from the variable x is less than 14, and x is greater than 2. So that would be how you describe the possible values of x. All right, number 5. Which of the following sets of numbers can be the lengths of the sides of a triangle? What are you trying to do here? Michael? No? No? Okay, David?
add the 2 numbers before, and if it's greater than you can try.
Basically, you need to make sure that whenever you add 2 numbers, that it's greater than the third. Okay, so if any of the cases don't work, then it's not going to work. So you could try out each one, and you would end up getting A, because if you added all 3 types of scenarios like this, so 12 plus 9 and that would be have to be greater than 4 if you did that one. And then you would try the next one, 9 plus 4 has to be greater than 12. And then you try the last one, 12 plus 4 has to be greater than 9. That'll test out each set of sides. So it has to be, the two sides have to be greater when you add them than the third side. Okay, so that works all 3 times. If you did that with the next one and B, C, and D, then you would have at least one where it would not work. So that would have to make it A. So A would be the following set of numbers that can be the sides of a triangle. Number 6, write an inequality relating angle 1 to angle 2. Basically, which one is greater? How can we tell?
The biggest side I wasn't used to know are just angles, so 8 is greater than 4, so angle 2 has to be greater than 1.
Okay, so yeah, if you looked at the sides, the side across from 2, angle 2, is 8, and the side across from angle 1 is 4. So that would make angle 2 greater than angle 1. So you could do angle 2 is greater than angle 1. Next one, similar to that one, but it's the opposite kind of thinking. So this is related to the hinge theorem, just in case you were wondering. What would be number 7 if we were relating the two sides? You want to try that one? You don't have that page. That's the second page. You should have that page. You have 2 of the same. Oh, you should have told me that. Okay, Amy. EF is greater than AD, and how do you know that?
Because the angles with the angles,
Yeah, okay, so just like we did with the sides to the angles, we could do the angles to the sides. So the greater angle is for EF, or across from EF. So EF would be greater than AD. Okay, number 8. Also similar. This is just writing an inequality about the length of AB, though. What can we say about AB? Or the length of AB? Okay, and I want to make sure that we are.
Ms. Roderick,
Yes.
do you have